Hi there, and welcome to 272analytics.com's tutorial on Markov switch models in Stata. Now, as with anything else in Stata, there is an immense amount of complexity surrounding the mswitch command, and I certainly won't be able to cover all of it. I just do want to give you a quick illustration of a simple use case that will teach you the appropriate code and some of the intuition behind what we're doing. And I'll leave the more complicated exploration to you through a search maybe of the Stata documentation or other sources. Now, this first series of commands that I'm going to enter is just so that I can regenerate some of the random variables that I used for an earlier time series data set that was really designed to find a structural breakpoint. I'm going to use the same random data here again because they provide a pretty good example of how to do Markov switching. And so what I'm doing here is the set seed 1, 2, 3, 4 command is what I used previously in order to key my random data. So by entering this command, I'm now going to be pulling up the same random data that I did before. I've created 1,000 observations, and what I'm going to do is I'm going to enter a bunch of code here at the same time. And if you're interested in a more detailed look at it, I do recommend that you look at the structural break test tutorial, which is also available from 272 Analytics. But let's go through it really quickly. I have created a new variable try for Turkish lira, and I created an artificial breakpoint here starting in observation 501, where the previously randomly generated variable had 0.5 added to it in all cases. I created a new variable for day and made it run sequentially from 1 to 1,000. I tsset it, telling Stata that that was a time series variable. Then I did a regression, and I followed that up with the estat sbsingle command to find a structural breakpoint. So that was a whole bunch of stuff that got done, but at the end of it, we found out that there was in fact a breakpoint at 501. Something changed there, and we know that not just because I created the data to artificially generate that effect, but also because if we did this time series line and notice that I put in xline 501 to represent the break, you can see it. You can see that there's kind of a before period and an after period. In the before period, the Turkish lira is relatively stronger against the dollar, and in the after, it's relatively weaker. But there's a whole lot of variation here and a lot of overlap. And so what we'd like to do now with the Markov switch model is to quantify these two states that we found. And really, once the data have been tsset, in this case, the variable day was tsset, all we need to do is type in mswitch dr, and then the variable that we're testing, which is try for Turkish lira. And once again, this is the simplest version of the Markov switch model I can show you. There are a lot of variations that you can try. So now we're going to run that model, and it's showing us two states in the data, which, hey, it makes sense because I made sure to create two states there. In the first state, we kind of see that the mean value of the lira was about 3.28. And in the second state, the value is closer to 4.29. And if you recollect, there was that break, and I showed you how there was a period where the lira in the fake data set was weaker against the dollar, and another period where it was stronger. That's what's being caught here. So in this state, the dollar buys fewer lira, and so the lira is stronger. And in this state, the dollar buys more lira. So the dollar is stronger, relatively. And what we get here then is, this is an important part of this readout. P11 means a probability of state 1 remaining state 1. Okay? So here we have about a 0.65. So let's say 2/3. There's about a 2/3 chance that when the lira is in that a powerful stage where it's a little stronger against the dollar, that it's going to remain in that stage. P21 here is the probability of stage 2 giving way to state 1. And we see that that's about 41%. So we see here that neither of these states, I beg your pardon, is especially persistent. If this, for example, was like 0.98 something, we would then conclude that once the lira is stuck in that state 1, it really stays there. It takes a whole lot to budge the lira out of there. If P21 was very low, like 0.02 or something, we'd conclude the same thing. We'd say, hey, in those periods where the lira, or in that period where the lira was observed to be much weaker against the dollar, it kind of stayed there. It didn't easily go back and revert to the first state. So the Markov switch model is really interesting because it leads to, a quantification of these stages in, or these states rather, in the data. And if you've carried out a Chow breakpoint test or a structural breakpoint test, and you found a break, a very, very obvious next step is to do the Markov switch, so that you can find out a little bit more about those two states whose existence was tipped off by the estat sbsingle command. And in particular, this information is very important because it tells you how persistent those states are. Now, this would be very valuable if you're doing some kind of foreign exchange analysis, stock market, maybe even predator prey kinds of relationships. Any time that there are two states, and you're interested not just in quantifying the states themselves, but in understanding the probability of switches from one state to the other. That's what the mswitch dr command is for in Stata, and as with almost everything in Stata, it's quite easy to carry out. I hope this tutorial was helpful to you, and I would like to invite you to visit 272analytics.com for access to all our free statistics tutorials in Stata, SPSS, R, eViews, and Minitab. Here at 272analytics.com, we provide data consulting primarily to graduate students. Therefore, we work very closely with you in order to perfect your Chapter 3 and Chapter 4. That means helping you design surveys, getting your data input, assisting you with fashioning appropriate research questions and hypotheses, getting your data, extracting them, transforming them, cleaning them, putting them through analysis, interpreting them, explaining them to you, so that at the end of the day, you know exactly what story your data tell, why they matter, what they mean, in a manner that lets you write a perfect Chapter 4, following a perfect Chapter 3, and lets you defend your dissertation or thesis with complete confidence. We provide ethical consulting. It's not a writing service, so you will be responsible for taking our blueprint, our assistance, our consulting, and transforming them into an appropriate academic project for yourself. I'd also like to remind you that we provide the same services to undergraduate students who are working with quantitatively oriented assignments. Thank you so much for listening, and have a great day.